Hello everyone. Can you hear me? Hi. Can you hear me? Today is it's my first live class. Hi friends, can you hear me? Is anyone with me? Hello. Please reply. Today we will solve some problems on current electricity. Yes, Rajdeep, you are here with me. Okay, anyone else? So Rajdeep, you are from which state? Rajdeep, can you hear me? Please, Rajdeep, reply. Okay, you are from Arunachal. Okay. So anyone else? Okay. So you are from which college, Rajdeep? Anyone else? Please reply. Yes, of course, Rajdeep. Yes, of course. Please, please do it. Yes. So today I am taking the first live class and I'm a little bit nervous in fact, and when I came live on 8 p.m. the weather conditions sent me to hell and I couldn't continue. So anyone else? If anyone else, please reply. Today we are going to solve problems on current electricity. Okay, you are from Cotton University. Okay. In which stream? Which subject? Rajdeep? Hello, Shravani. Hi, Shravani. So, may I know you are from which state, Shravani? Please reply, guys. Anyone else today? Okay, you are from Maharashtra. From where? Mumbai. Are you from Mumbai? The state of Corona right now. Tell me. Okay, anyone else? From Nanded. Okay. Okay. So anyone else? We are running off time. Running out of time. Should I start? Should I start? Rajdeep? Okay. Ruby joined us. Hello, Ruby. Anyone else? So, Ruby, you are from which state? Okay. So, should I start? Okay, you are also from Cotton University, Ruby. Okay. So, I should start now, I think. So we are going to solve problems on current electricity. So these problems came in previous year JAM biotechnology papers. Okay. So please keep replying, because then I'll understand that you guys are with me. Okay, Shreya joined us. Shreya, last time I couldn't continue my live class. So, can you all see me? Is it clear? Is my voice clear? Okay, this is the first question I should discuss first. So, here a circuit is given where you are asked to find the current flowing through the ammeter, that is this ammeter, okay, and this circuit is a little bit troubling, right, because there are a lot of resistances. This, okay, sorry, these resistances, right? So, okay, so can you yourself solve this question? So let us solve this question together. Okay, first I'll give 1 minute actually to you to understand this, and tell me if you can solve it by yourself, and then I'll solve. So your time starts now. Please try to solve this. So let's see who can solve this. So tell me if you can solve this, or I'll start solving this. Okay, in this time we should recapitulate that if some resistances like R1, R2, R3 and some other resistances are in parallel, in series, right, like this, and in this way, this is Rn, nth resistance, right? Yes, Rajdeep. Okay, your answer is 0.2 ampere, right? Okay, I'll not give the answer right now. Let's see what is what answers we get from others. Okay, so Rajdeep's answer is 0.2a, that is option B. So let's see what others answers. So in this question, in this case, that is when this R1, R2, R3 and up to Rnth resistance, these resistances are in series. So the equivalent resistance in this case is Rs, that is equals to R1 plus R2 plus R3 plus dot 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 Rn up to Rn, right? That is the summation of the resistances. And in case of parallel resistances, that is when R1, R2, R3 and Rn are in parallel, right? Then the equivalent resistance, the formula for equivalent resistance is 1 by Rp, where Rp, the equivalent resistance, is equal to 1 by R1 plus 1 by R2 plus 1 by R3 plus dot dot 1 by Rn, right? These are two formulae for series, equivalent resistance in series and equivalent resistance in parallel. Okay, and another formula we should consider, that when these resistances are equal, that is when R1 equal, R2 equal, R3 and so on, then this equation becomes, suppose it is equal to, they are equal to R, okay, and the number of resistances is N, okay, then the equivalent resistance is Rp equal R by N, okay. So we should consider these three formulae, okay, and now we should go back to the problem. So only Rajdeep has an answer for this question. Anyone else? Ruby, Shreya, Shravani, anyone else? Do you want to answer? Please reply. Or should I proceed? Please reply. Anyone else? So no one is answering, so I should carry on. Then see, let's redraw the circuit, okay. See here, okay, Shreya is saying that she haven't revised the chapter, okay, Shreya. So let's revise together. See, this two resistances, there is 5 ohm and 5 ohm. See, they are joined, just joined here, right? That means these two resistances are in series with each other. So let's redraw it. So this is 5 ohm, this is 5 ohm, right? So these two resistances are in series with each other, and they are, see, the end of one resistance is connected to this 10 ohm and the end of other resistance is connected to this 10 ohm, right? So these 5 ohm series resistances are in parallel with this 10 ohm, okay. Now again, this pole is in series with this 10 ohm, okay. So let us draw it. This is 10 ohm, and now this is in series with this combination. See, this structure is just the same as this one, okay. So this is 10 ohm, this is 20 ohm, and this is they are in parallel with 30 ohm, and here is the ammeter. Here is what is happening here. Okay, here is the ammeter. Ammeter, and it is in series with the battery of 6 volt. So we could redraw this circuit. Is it clear to you? Please tell me. Is it clear to you? We redraw this given circuit. Is it clear to you? Everyone please reply. Could I make you understand? Okay, Shreya, you could understand. Anyone else? Please reply. Okay, I think it is clear to you. Now I should proceed. So we can redraw this one as, see, these two resistances are in series, right? So we can use this formula, that is, just add the resistances, right? Just add the resistances. That means it becomes 5 ohm, 5 ohm means 10 ohm, which is in parallel with this 10 ohm, right? Is in series with 10 ohm, and again this 10 ohm and 20 ohms are in series. That means this becomes 30 ohm, and it is again a 30 ohm, right? So this is here, then a ammeter and a battery. Now this can be again simplified as, see, this one is 10 ohm, which is in parallel with another 10 ohm, right? So it becomes 10 by 2 means 5 ohm, right? Because these two resistances are equal and number of resistances is 2, then R is here 10 and N is 2. That means this is 5 ohm, which is in series with another 10 ohm, and again it is series with, here see, this is 30 ohm and this is again 30 ohm. That means 30 by 2, it again becomes 15 ohm. Okay, so it is okay, so it becomes this. Again, if we simplify this one, we get, see, these 5, 10, 15 ohms are in series, right? That means this becomes 30 ohm, right? 5 plus 10 plus 15 means 30 ohm, and we get the simplified circuit as this, right? And here flows our current I. So now we have V equals 6 volt, R equal 30 ohm, and we don't know how much is I. Okay, so by simply using the formula V equal IR, okay, this formula that implies I equal V by R, and it is 6 by 30, which will give you 0.2 ampere, right? So the correct answer is option B, 0.2 ampere. Okay, so Rajdeep, you are correct. You gave the correct answer, 0.2 ampere. So is it clear to everyone? Please reply. Please reply everyone. Is it clear? Any doubt? Please reply. Okay, Shreya, Rajdeep. Everyone else? Is it clear to everyone? Okay. Should I proceed? Should I proceed to the next problem? Okay. Okay, Shreya. So I should proceed to the next problem. see, this is our next problem. So last question, the first question came in the year 2013 in JAM BT paper, and this question came in 2012 in JAM BT paper. So let's solve it. Okay, so let's solve it. In this circuit, the question is, in the given circuit, an ideal battery of 15 volt, that is this one, and resistances of 4 ohm each. These 1, 2, 3, 4 are not the values of resistances. Okay, these are just the numbers. The question was like this: 1, 2, 3, 4, but these are not the values. These are just numbers. So each we can write it is 4 ohm. Okay, 4 ohm. Okay, 4 ohm each are connected as shown below. The current through the ammeter is 18.8, 3, 2.5 or 1.9. Okay, so see, can you solve it? So let's see how many of you can solve it. So I'll give you 1 minute to tell me if you can solve it, if you want to try. How many of you want to try by your own? Tell me. Rajdeep, do you want to try it? Can you solve it? Okay, Rajdeep, try it. Okay. Ruby, can you try it? Can you solve it? Shreya? Anyone else? Yukta? Do you want to try? Shravani? Okay, Rajdeep. Rajdeep is trying. So anyone else? Okay. So let's draw the circuit. Okay. So first of all, see this resistance. Okay, Ruby, you are trying. Okay, tell me. Okay, I'm waiting. Tell me, what is the answer? What would be the answer? Okay, wait, I'm waiting. Okay, Ruby, I'm waiting. Rajdeep? Rajdeep, can you solve it? Okay, so I should proceed, right? Okay, see, these two resistances are connected in parallel. See, these resistance and these resistance, these two resistances are connected in parallel. Why? Because the two ends of them are joined, right? Joined with each other. Like this, each of these four, this one, this one, this one and this one. Okay, these four resistances, these last four resistances, this. Okay, these resistances are in parallel. Okay, so okay, Ruby, could you solve it? What is the answer? So these four resistances are in parallel. Okay, So this is 4 ohm, this is 4 ohm, this is 4 ohm, this is 4 ohm. And see, this 4 ohm resistance, this 4 ohm resistance is in series with this one. This seems to be very clumsy. Okay, this 4 ohm resistance is in series with this one. So it is in series with this, the first one, right? And this is in series with ammeter and the battery, and then joined with this. Okay, okay. So Rajdeep got the answer. He says it is 3 ampere. That means option B. So let's solve it. Anyone else? Ruby, could you solve it? Okay, so this is 15 volt, the battery is of 15 volt. So this is the equivalent circuit, right? So this circuit, we can redraw this circuit. See here, 4 ohm resistances are in parallel, right? That means here R is 4, N is 4. That means the equivalent resistance is 4 by 4 means 1 ohm. That is, this is 1 ohm which is in series with 4 ohm, and this is our circuit. And if we simplify this, we get this is 1 ohm which is in series with 4 ohm, right? That means it is actually 5 ohm which is in series with ammeter and a battery. And if we complete this circuit, it becomes this. Okay, so this is our circuit where V is 15 volt, R is 5 ohm, I is V by R, right? That means 15 by 5, that is 3 ampere. Okay, that means the correct answer for this question is option B, 3 ampere. That means Rajdeep, you are correct. Okay, Shreya, you are facing a network problem. Okay, no matter. So we could solve this problem. So should I proceed to the next question? Have any of you any doubt? Please tell me. Yes, Rajdeep, it's option B. You are correct. It's 3 ampere. So should I proceed to the next problem? Please tell me if any one of you have any doubt. Okay, I am going to the next problem. So this question is from the year 2018. Okay. So, okay. This question is from the year 2018. Here the question is, a metallic wire of electrical resistance 40 ohm is bent in the form of a square loop. The resistance between any two diagonally opposite corners is how much ohm? Okay. So, do you want to try? So let's tell me. Do you want to try, or let's solve it? Should I proceed, or do you want to try? So here given is a metallic wire of electrical resistance 40 ohm. So we have a metallic wire which have electrical resistance 40 ohm. Okay, this have resistance 40 ohm. 40 ohm. Okay. Okay, Rajdeep's answer is 10 ohm. Okay, let's see what is our answer. What we get. Anyone else? Ruby, do you want to try? Ruby, do you want to try? Anyone else? Anyone else? Come on, tell me if anyone else wanna try. Okay, I don't think anyone else want to try. So see, this metallic wire which has resistance of 40 ohm, we can redraw this wire as the series combination of 4 10 ohm resistances, right? This is 10 ohm, this is 10 ohm, this is 10 ohm, this is 10 ohm. It is just equivalent to this one, because we know that the equivalent resistance of 4 10 ohm resistances in series is 40 ohm. Okay, so we can now in this question you are asked to bend the metallic wire in the form of square loop. Okay, so this can be redrawn in this form. Right, this metallic wire is just bent in the form of a square loop where we get each side having resistance 10 ohm. Clear, everyone? Yes, Rajdeep, due to weak network, it is happening. Okay, so we get each side as 10 ohm resistance, right? So now we are asked that the resistance between any two diagonally opposite corners. Okay, we are asked to find the resistance between any two diagonally opposite corners, right? So let us think this as the diagonal where we want to calculate the equivalent resistance, right? This is A and this is B. We want to calculate the equivalent resistance between A and B. Okay, this is the diagonal. I hope everyone knows that this is the diagonal, and so we want to calculate the resistance, equivalent resistance between these two corners. Okay, so let's redraw this circuit. It becomes 10 ohm, 10 ohm in series because these two 10 ohm resistances are in series, right? So this is 10 ohm, this is 10 ohm, and again this is 10 ohm. These two resistances are 10 ohm each because they are in series, right? So 10 ohm, 10 ohm. This is the point A and this is the point B. Okay, So these two resistances 10 ohm, 10 ohm, they are in series, and these two resistances are in series. That means it becomes 20 ohm, 20 ohm in parallel, right? Is it clear to everyone? Please reply. Please reply, guys. Is it clear to everyone? So it becomes, see, these 20 ohm, these two 20 ohms are in parallel to each other. That means we get the equivalent resistance as 10 ohm. Why? Because we know here R is 20 and N is 2. That means we get RP as 10 ohm. That means between A and B, that is the two diagonally opposite corners, the resistance, equivalent resistance between the two diagonally opposite corners is 10 ohm. That means our answer is 10 ohm. Is it clear to everyone? Please reply. Is it clear to everyone? Is it clear to everyone? Please reply. Any doubt? Anyone? Okay, Ruby. Okay, Rajdeep. Yes, again your answer is correct. Okay, so let's see another question. Now let's try this one. Tell me if you can solve this. This is our last question today. So let's solve it together. First you try. So do you want to try? This question is not on resistances but similar to that is on capacitors. Okay. So you are asked to calculate the equivalent capacitance of the assembly of capacitors. So tell me, do you want to try this? Okay, Rajdeep's answer is 1 microfarad. Okay, anyone else? Anyone else? Come on, tell me. Anyone else? Ruby? Ruby? Anyone else? Do you want to try? Okay, I think I should proceed. So, here, see, we solved the previous questions where we were asked to calculate the equivalent resistances, right? But here, we are asked to calculate the equivalent capacitance. Okay, Ruby? Yes, I can understand. So, can I ask you one question, Ruby? You're from which what is your subject? Which stream you are from? Okay. So please give me reply and I should proceed. Okay. See, in the previous questions we solved the problems where we were asked to calculate the equivalent resistances, but here we are asked to calculate the equivalent capacitance. Okay, and the formula for equivalent capacitance is just the opposite in case of equivalent resistance. Okay, that means in case of series capacitors, okay, when capacitors are in series, the formula is equivalent capacitance. The formula for equivalent capacitance is 1 by Cs, that is the equivalent capacitance in series is equal to 1 by C1 plus 1 by C2 plus 1 by C3 plus up to 1 by Cn. Okay, if it is nth capacitor. Okay, this is Cn, C3, C2, C2, C1. Okay, this is the formula for capacitors in series. Okay, and okay, Rajdeep and Ruby, you are from biotechnology. Wow, great. So, are you sorry, I shouldn't. Okay, so are you doing honors in it or what? So when these capacitors are in parallel, right, the formula becomes, if it is C1, C2, C3, C4 and up to Cn, okay, they are just added up and we get the equivalent capacitance as Cp equals C1 plus C2 dot Cn. Okay, this is the formula for equivalent capacitance in parallel. Okay, so now if we solve this, we get, first redraw this circuit. Okay, so see here, two microfarad capacitors are in parallel, right? Then they would just add it up and we get 4 microfarad capacitors, which is in series with this 4 microfarad capacitance. Okay, again see here, we have 1 microfarad, 2 microfarad, 1 microfarad. These three capacitors are in parallel. That means it would add up and we would get the capacitance as 4 microfarad again. And again, the 4 microfarad is in series. Okay, this is the equivalent circuit or the simplified circuit. So we have 4 microfarad capacitors, right? So they are in series, and if we apply this formula for equal capacitances, then we would get Cs as 4 by 4, that is 1 microfarad. Okay, so the equivalent capacitance is, equivalent capacitance is 1 microfarad. Okay, so our correct answer for this question is 1 microfarad. Okay, so Is it clear to everyone? Yes, Ruby, it is 1 microfarad. Is it clear to everyone? Anyone else? Please reply. Is it clear to everyone? Today we solved 4 questions from current electricity part, which came in JAM Biotechnology paper, previous year JAM Biotechnology paper. Is it clear to everyone? Okay, so this is all today, and I hope I could successfully make you understand. So if you want more videos like this, please follow our channel and stay tuned with us. So goodbye and good night everyone.